Hey there, friend. So on Sunday, I did a talk at an event on building resilient AI agents. Basically, looking at some of the work that my team has done over the last 18 months. We've actually been doing a ton of work on AI assistant pen testing. So, chat bots, basically, the standard like ChatGPT style applications that are kind of a wrapper around a model and has a lot of user input. Ask a question, get a response. We've also moved into the AI agent or multi-agent testing as well. So I want to give kind of a quick update and kind of a step through of some of the topics that I talked about at the event. Just share it with you and the wider audience. So kind of stepping through it a bit. Let's see what we got here. I'm going to skip over some of this. So if you don't know me, this is just some of the background, a couple of claims to fame, if you will. I've been working with one of the big four. I've actually worked for two out of the big four over the last 4.5, 5 years. I'm doing a lot of pen testing for their systems. Also, in terms of, I provide CISO services. Basically, I am the CISO at SmartPay. I provide them, basically building their security infrastructure as well. And I was previously the CISO at Paidy. I helped them really build their security and security team, bring them up through becoming an Amazon payments provider and eventually being acquired by PayPal. However, I left before that, but the foundations of what I built there, along with the team, helped that happen. Along with a ton of work that happened after I was gone. So, kind of what I look at, why AI agents. Actually, AI agents is a huge market. It's only growing. Right now it's 4.38 billion. It's growing. 2030, I think 47 billion is probably on the conservative side. I think it'll be even bigger than that. So kind of, what is the difference between an AI agent and an AI assistant? So when I look at it, an assistant really is, I have a question, I get an answer. It really is kind of I ask one question, I get one answer, and I might have a couple of questions as a follow-up, but all of those take my interaction with the system itself. AI agents, however, is more like, I'm replacing or automating a role. So it's more like, hey, I want something done, and then I can give it to multiple agents, and each one of those are specialized in their own way. They'll find out the best tools and processes to deliver the results that I'm looking for. So it's very much an autonomous process, and I'll step through what these are in a bit more detail as we go. Again, if you focus on AI assistants, this is what a lot of people are using for, like support, chatbots, or different free tools on websites. Like, here's my URL. Take a look at my website. Give me back some feedback on it. Or maybe I have, I go to a website and I ask some questions. So maybe it's all purchase or post-purchase support, basically. If I look at the AI agents, however, it's very much, hey, I have this thing I want to do. So for example, it could be I want to write some content, and maybe you have a specialist that's a researcher agent. You have another one that's an expert at writing content. You have another one that's an expert at scoring the content based off of brand guidelines and those type of things. So different use cases around this might be internal processes like sales or marketing. For example, being able to take a sales or marketing lead or prospect and score it. Maybe take in the security side, maybe it's take this network diagram and convert it into a threat model, which we'll go through in a bit. Again, kind of what are the parts that make up an agent? You have the task, you have the actual agents that are part of the process, and you have the tools that they have access to. And two of the interesting things that an agent has is the ability to ask another agent or another coworker, if you will, or the ability to delegate work to the other agent. So In this case, maybe down here toward at the top, you have a researcher, an industry analyst. Those have access to tools like search or find a similar website or get the content of a website. Maybe the agents down here, like a median strategist or writing a summary. Those don't have access to the same tools, but if those agents need help, they can ask one of the other agents for help, or they can even delegate the work to them. So it gets a lot more involved, I would say, a lot more advanced. Kind of, how do they think, or overall, if you look at an agent, they really end up using the LLM to help them think. So you give them an action, like, hey, I want you to do this, create a post for me. It'll then send a prompt to an LLM with some other data along with it. Actually step through the process to think, what are the next actions that I should follow to be able to solve this? And it'll keep going through this cycle until it actually comes up with an answer. So one request might end up being, one or even, hundreds or even thousands of requests to the LLM to get more details until it kind of digs down deeper to be able to get to the answers that it thinks are correct. And this is, the images I've been showing here are actually from crew.ai. And if you look at here, kind of the processing, it uses a reasoning as well as some actions and observations. So this is the cycle it goes through. It goes through, a reasoning steps, and those are tied in with some actions. So it's like, this is the question I have. What are some other questions that I need to ask? Here are some actions I can take, and some observations that come back from it. So it's a very different process, but one of the biggest advantages that this has over, say, chain of thought type is it helps to reduce hallucinations, for example. So all of this in the security context is like, what is the purpose of security? So we talked a lot about AI, and I think at the end of the day, security really does, its focus is no different than the rest of the business. It helps to eliminate risk, but actually it's not about elimination. It's about helping to reduce and manage risk. But it's all in line with the business. So the reason I talk about this is because if the business wants to embed AI in different applications or bring it to market so that their customer helps support the customers, if the traditional security department just says no, that really ends up resulting in shadow IT. So you bring, one of the departments comes to you and says, hey, as part of the security team, you're like, hey, we want to bring this tool to market, and the security team doesn't know how to handle it or doesn't want to work with it. They're like, simply, no, we can't do that. The same thing for internal engineering teams, where it's like, they bring an idea, like, hey, we want to do this. For example, building out a chatbot for the website. If engineering or security say no, like, the teams are still going to do it. They're going to find a way to work around, and that's that brings on a lot more shadow IT. So it's not about saying no; it's just about risk management. One of my favorite quotes is actually, when asked why he robbed banks, Sutton simply replied, "That's where the money is." So this is why I think security has become way more important, especially around AI, and it's because like that really is where the money is. So it's the same reason for if you have credit card fraud or just fraud in general, where the fraud itself is more profitable than the cost it takes to block it, like it'll always exist. It's the same thing here. So I don't see this slowing down. It's just about how do you manage risk and how do you reduce the overall time to response. So kind of talking a little bit here, I kind of want to just touch on two different platforms. One is very much a code-first solution. That's the Crew AI. The other one is the N8N. This is much more of a WYSIWYG front end. However, it can, you can actually code in it. Both of them have both self-hosted as well as some cloud-hosted models or alternatives or whatnot. Both of them have actually really big communities. So if you look at I kind of put together some high-level diagrams. So this is what like a cloud environment might look like, and this is just a couple of examples. So one of the examples that I'm working with right now was for this presentation anyhow was about generating blog post content with a couple of different agents. One to actually research ideas, another agent to write content for the agent for the ideas, another one to score the content based on a brand brief. And if it, the content that was written, if it goes over a certain level, then it gets written out to a service here called FeedHive, and they're actually the ones that put together the example here that I'm talking about. So not to just take credit for what they've done. So, but their actual tutorial was actually really interesting. So for NA10, that platform itself is actually more on the newer side for me. So I look at it from a risk perspective, and risk could actually end up being, this is it's a UI first, so it could be around access control, having users have access or make changes that they shouldn't be making, or it could be more in the cloud environment where maybe the cloud hosted cloud environment has access or permission issues or vulnerabilities there, or logging sensitive data, for example, to the internal logging systems, or for example having a user going through a UI and create their own endpoints. So instead of sending it to the ones that are pre-built, you have the functionality to be able to just add your own endpoints where you want to have data be sent. So basically data disclosure. And then looking at kind of like the self-hosted solution around this. So I thrown a couple extra pieces in here, but basically it's a very basic three-tiered architecture. But it really does focus on many of the same problems, and as a result of this, we have a lot of the same issues. So it still ends up with, around user access controls. It has the questions regarding like a TLS. Hopefully, you've included TLS on internal networking connections as well. So there's an opportunity internally for both, depending if you've configured TLS, or for example, to have man-in-the-middle attacks or information disclosure if somebody can actually catch or even tamper with the transmissions that are going internally. Logging is one of the big ones, because if you're processing especially sensitive data, it can be written to logs unexpectedly. And then again, just being able to go through and configure other external endpoints that data can be sent to after it's been processed. So looking at this, we kind of have to step back and think about where do we manage risk, or how do we manage it rather. So it's funny, we talk about AI agents, they need context to work, and for example here I'm also giving a scenario, which is another words of saying I'm giving us context to help us work. It makes me wonder who's the bot. So joking aside, so here's just an example. So you have a company that's pretty AI or technology early adopters. They are growing very rapidly. They don't have a lot of additional budget perhaps because they're expanding so quickly. They work in either a regulated environment or it could even be a non-regulated, but for this case we're talking regulated. So a lot of controls around the data and sensitivity around the data they're accessing. So how might a company like this use agents? And it's not just one or two departments. It actually could be in any department that they have in the company. So it could be the sales and marketing teams, accounting, the security team. But it all comes down to, I think in many ways, it all starts with data classification. And if you just look at a very simple like ISO type approach for data classification, you have like public, internal, or confidential. And I'm highlighting the PII, or personal identifiable information, kind of separately here because, in Japan, for example, there are multiple classes of PII. In other countries, it's a bit different, I'm guessing. So, the challenge here is if you look at marketing, maybe content creation is public content designed to be published on a website, so it's public. But lead generation, that can include things like email address. you know, email address in Japan versus like GDPR over, you know, in Europe might have a different definition if it's PII or not. It really depends on the specific use case. The sales team as well. So if you're doing like lead scoring or prospect, you know, targeting, that could, you know, there's probably either internal or confidential as well because you have customer contact details there, addresses or phone numbers, whatnot. The same with accounting. Well, accounting is most likely either confidential or internal as well. You know, you talk about, you know, how processing invoices or drafting payments. So it could, you know, that could definitely include a lot of very sensitive data. And the interesting thing around this is like payments, for example. Like if you look at Japan, how you handle bank account information is generally, you know, you see a lot of websites that actually bank accounts made public, which you would never do that in the U.S. The U.S. would be held much more close, and you wouldn't give that information out. But you know, I've seen websites in Japan with bank account details published as actually quite common. So it really comes down to data classification. And the challenge with this is like maybe a marketing team, they'll end up treating multiple roles very similar. So they're like, oh, content creation is public. Everything we do is public. But that's really not the case. And if you look at a tool like N8N, which is designed for non-technical people to be able to do some pretty cool, you know, AI agent work. If you don't know what the risks are, so for example, you don't know that, you know, you're going to be sending emails to third-party systems, that's a problem, then you're not going to know, you know, there's nothing there to stop you. At the end of the day, like if it all comes down to training and awareness. Here's an example of like the N8N flow. So if you look here, we have it's just a manual trigger at this point, but it could be really tied up to anything. It could be a schedule, but really the idea is like this flow here is to generate content. So I click a button, it starts the agent process. It can do things like, hey, I'm going to be using this AI chat model that I've fine-tuned with some example code of mine, or sample data of mine. I can get my brand brief. I can generate content itself. So it actually goes through and it uses some ideas and information. So in this example here, I'll write a message like, hey, you know, write a LinkedIn post that we need more founders, or hey, write a post that we need, you know, starting an AI or a SaaS startup. And it will use this information to go through and it will generate new additional posts. And it will do that by taking an idea, writing some content. It'll pull in a brand brief, and it'll score it based off of my brand brief and some, you know, characteristics. And the interesting thing here is that these different agents will interact with one another in order to be able to create good content, and it'll be able to score it so that it keeps it in line with what the brand brief is. And if it meets the requirement, it will then send out and publish that content. So for example, to FeedHive. Or if it doesn't meet the certain score, what it'll do is it'll go through and it'll loop again. It'll keep on looping through and writing and making improvements. It'll ask other agents, hey, how do I make this better? The agent will then rewrite it, and it'll go through this process until it reaches that score. So, you know, it does work autonomously once it's triggered, and again, you can have triggers. It could be everything from time to an event. What I've done here is I've actually gone through and I've taken this original diagram along with this, you know, generating, you know, public content, and I've created a threat model out of it. So a threat model is a simplified diagram that helps you really focus on the end-to-end data flows as well as, you know, the high-risk points, because those are the areas you're going to want to test. So to kind of zoom in here a little bit more, we have users that would interact with the system. Notion is what I was using in my example to pull in my brand brief. It can then send, you know, requests from agents to OpenAI to then, you know, to think rather, so it can, you know, send requests to kind of work through the process of functioning. It can go through, and I've included dependency libraries, like pulling in dependencies, build and deploy pipelines, as well as being able to build Docker images depending on where you want to run the application. So, we'll run on standard compute, or one of the interesting things about both of these models is they come with pretty good support for Kubernetes. So if you want to build in a container and push it to Kubernetes to be able to scale your jobs, it's pretty interesting, pretty straightforward. Around compute. So compute really, it doesn't really tie to any specific device, but for the most part, you need to be able to run, I would say services that kind of go continuously. So it's more like in Kubernetes where you might have a service running. So it's much more of a service than a job, I guess. And then you have external services like FeedHive, where you want to be able to push the content once it's met the scoring. Now, when I was looking at this example, I went ahead and I used ThreatDragon to run through like a stride threat modeling, so that I could actually pull out some examples. So, for example, in one of these cases, I was able to find that when you make a request to actually publish the content, the access tokens were actually being set via an HTTP GET request as a parameter in the URL, which actually isn't secure, because then one is being sent by a GET request, so actually it could be cached. The other part of it is it could be saved in logs. So I was kind of going through this process up here. I was kind of looking around to see what types of things I could find. And in this case, it's like, all right, what is the mitigation for this? So I didn't actually test this. This was just me stepping through the system to understand kind of how it worked. And the important thing here is that threat modeling is not an individual sport. So generally, you want to get everyone involved. The developers, the security team, the project owner, the product managers, really anyone who who's involved in a project. You want to make sure that they're helping kind of step through it. Because as you kind of go through and you do testing, you might find findings in high-risk areas, then it could have impact on the overall project. So again, threat modeling is a team sport, not just security. And the cool thing, if you're from a security team, if you're thinking about if you go through and you do involve the other members, the first or second time is a bit rough when people aren't familiar with threat modeling. But what I found from experience is that when you work with teams and you go through the same process multiple times, they eventually start doing threat modeling themselves before they get to the threat model. So it actually helps to internalize this process in each team. The other thing is, every component that's in scope should be read, meaning it does have a threat or a risk associated with it. Otherwise, it's incomplete. So you should be testing at least something on every component that's in your environment. Otherwise, it should be out of scope. And then you always wrap up with a question. It's like, hey, are there any parts of the system that either make you uncomfortable or that you think we should be testing more thoroughly? That's a wonderful question that generally you can go through the whole meeting, you get down to the last question, and that's where all the gold is from a risk perspective. That's where a lot of the questions really come up, because the developers that are building it know the system inside and out, and they have their areas that if they're asked, they'll share them, but if they're not asked, they generally won't. So just some common attacks as I wrap this up. AI assistance, a lot of it ends up being around prompt injection. So being able to break the guardrails that AI systems have put in place. And for example, social engineering, one of my favorite examples is actually from a GitHub repo that basically outlines a bunch of different examples, and one of them is like, let's role play that, hey, we're part of the, that we're doing the Star Wars, and we have the Republic and we have the Jedi, and they're fighting off, and going through this this process, it kind of starts to create some social engineering between the user and the AI model, which allows them to kind of bypass and break through the guardrails to get to answer things that they want. So, for example, building building a bomb or creating, a vulnerability or something like this. Another one ends up being around data extraction. So again, this comes back to prompt injection in most cases. It's around breaking the guardrails to be able to extract data from the system that they shouldn't actually have access to. And that's generally based on just poor design. Compare that with AI agents. So, this is much more difficult generally because AI agents usually are not public facing in the same way that an AI assistant might be. So it ends up being like, instead of prompt injection, it's much more around how do you either create a bias or you create different results than what you would normally get. And that could be by introducing additional agents into the configuration or replacing agents that exist with new, modified agents. Or, it's basically like altering or accepting the communication between the agents or disrupting the Cerberus overall. So a lot of this, if you look at the next one, it kind of breaks down to some of the mitigations here. So prompt injection is, input validation, social engineering the same, input validation. Data extraction is more about, response validation, so not directly sending or returning the data or the input or output directly that the user sends, that you actually do have some validation and some mapping. On the AI agent side, it's much more around access control, proper monitoring, limiting network internally by using TLS or mutual TLS to be able to restrict access between agents, or using zero trust so that you can actually limit point-to-point communications between resources even. And then it comes down to access control around disruption, and when it comes to you want to make sure that you have a secure build and deploy pipelines, infrastructure as code with the ability to identify when drift has happened. So for example, if an agent with a different SHA, for a commit SHA, so there's been changes to the code, has made it through the pipeline or has been replaced, and that compared to what the system's expecting, that is able to be rolled back or identified or flagged. So these are some of the different mitigations that are out there. Again, I appreciate the time here. If you'd like to chat more about AI agents or AI assistants or how to secure your environment, feel free to reach out. I'm more than happy to have a chat. I'm planning to, in the next week or so, to release a bit more content, kind of talking and stepping through around how to build some AI agents for common use cases. The one I'm currently working on right now is to be able to help to manage or at least tag and filter out phishing email much better than doing some comparisons with, for example, internal distribution lists. Being able to catch some of the spam issues that we currently run into these days. Anyhow, if you have any questions, let me know. Happy to hear from you. Cheers.